But just because I'm opting to use in-context blend shapes in place of traditional blend shapes does not mean that traditional blend shapes will be of no use to us in this project. Let's go back to the table I showed earlier to take a look at the alternative choices I plan on utilizing for clusters and sculpt deformers. These two choices rely on an intermediary traditional blend shape for their functionality. This approach is a very popular way of piping all your corrective deformations through a single target blend shape to your skin mesh. To further analyze the benefits of this approach, let's jump to the next choice and its alternate on the table. Advanced Skeleton's Custom Cluster Control option. When you are creating one of these cluster controls with Advanced Skeleton, you are provided with the option of mirroring the entire setup. This is a great feature. One thing you do have to pay attention to with every Advanced Skeleton cluster control you create is deformation input orders. Each one you create has to be moved to the right place in the input order stack so that it evaluates at the right time and correctly. If not, you get some wonky double transformation-like behavior when you attempt to use the control. This also does mean that each cluster control you add is contributing to the amount of deformations that your skin mesh has to evaluate when the rig is being used. This is where the alternate approach shines. Piping your clusters through a traditional intermediary blend shape with other corrective deformers means that the skinned mesh only has to worry about the input order of that one intermediary blend shape. So it's a set it and forget it situation where you don't have to worry about the deformation orders anymore, since all your deformers are coming through that intermediary blend shape. It's also nice to have the option of creating a simple cluster with no control system that can be used to quickly repair skinning issues. I'm sure if you wanted to, you can easily delete the control that Advanced Skeleton provides with its cluster. But for this course, I won't be doing that. I need both methods. Sometimes I'm going to want to use Advanced Skeleton's cluster with a control so that I can easily feed that cluster control to Advanced Skeleton's driving system and also have control of that cluster at animation time to do tweaks. And other times I'm going to want to just do a simple cluster fix on an intermediary blend shape that is triggered with Maya's set driven key system. So that is why these two options are still available on my solution tree. Let's look at the last set of alternate options. Just like with the cluster situation described above, when you apply a sculpt deformer directly on your skin mesh, it is forced to compete with other deformers concurrently. So all these deformers are firing off at the same time, and this has the potential to slow down or crash your rig. On the contrary, just like I described with the cluster situation above, when you apply a sculpt deformer indirectly to your skin mesh through a traditional intermediary blend shape, you are more so incurring the cost of that single blend shape on your skin mesh. Now ultimately, Maya still must resolve the sculpt deformer on this blend shape, but because this intermediary blend shape mesh is a stationary mesh, it is a less complex computation to resolve overall. Let's take a look at a practical example to help us understand what the performance differences will be. So in this file, the mesh or this cylinder is skinned to 5 joints, and there is a sculpt deformer inside this mesh right there, this sculpt deformer. And that sculpt deformer is skinned to a joint that is a child of this third joint right there. And I've created some animation, so let me scrub through the timeline and show you what's happening. The skin mesh is moving, right, because I'm animating the joints, and the joint that has the sculpt deformer skin to it is also moving left to right, so it's impacting the surface of the mesh. If I hide all of this stuff and go to 5, you'll see how the sculpt deformer is impacting the surface of the mesh. This joint that's housing the sculpt deformer is just moving left to right and just making the sculpt deformer impact the surface of the skin mesh. So this is a simulation of rigging a Sculpt deformer to impact your skinned mesh directly. Let's take a look at the alternate option. Now in this example, I have pretty much the same thing. So it's a mesh with these 5 joints skinned to it. But this time, the Sculpt deformer is impacting this mesh through an intermediary mesh. This mesh is a blend shape target of this. And the Sculpt mesh is impacting this mesh. So let's take a look at what that looks like when I scrub the timeline. I have the same animation from before, but this time the Sculpt deformer is on the intermediary blend shape. Right, impacting it in the same way. In both animations, this Sculpt deformer is moving 5 units to the left, 5 units to the right. So it's going left and right. But ultimately, it's producing the same kind of animation. Now let's take a look at what the FPS of both of these look like when we play this animation in real time. You notice how much faster the Sculpt deformer that's applied indirectly is computing compared to its alternate, which has been applied directly. So this test shows that we take less of a performance hit when we apply a Sculpt deformer indirectly through an intermediary mesh. So if a Sculpt deformer through a blend shape could potentially be a cheaper solution that causes less crashing and slowing down of the rig, why am I even still considering the option of applying the Sculpt deformer directly to the skin mesh? Well, because of the previously mentioned competitive advantage that a Sculpt deformer has over other deformers. If you remember in lesson 28, I pointed out that one of the major benefits of using a Sculpt deformer was how persistent it was at preserving its deformations when up against other deformers affecting the same area. When you go with the alternate option and apply said Sculpt deformer through a blend shape, it simply has the persistence level of a blend shape. Let's take a look at this difference in the two application methods with this example. So let's take a look at this scene that's going to help me showcase the persistence of a directly applied Sculpt deformer. In this scene, I'm using Advanced Skeleton's Blaze. As you can observe, he looks freakishly odd because I have some Sculpt deformers applied to him. I'm going to disable them temporarily so you could see what Blaze actually looks like. So I'm going to grab both Sculpt deformers and turn off their envelope. So this is what Blaze looks like. This is his default pose. So what I have here is an intermediary blend shape. And if I hit the 4 key, you'll see that I have 2 NURB spheres here that are positioned in the exact same location on both of these meshes. So this intermediary blend shape has one on the left side, and the main rig here has one on the right side of the figure. This NURB sphere is a Sculpt deformer that has been applied directly to this skin mesh. And this one has been applied to the blend shape. And as always, the blend shape is connected to the main figure. So if I select Blaze's body, you'll see that there's a blend shape node here, and it's been set to 1. So it's always on. All right, so let me turn these Sculpt deformer envelopes back on. And that's what we're getting, this really huge impact. I'm getting it by using a huge maximum displacement and a drop-off rate. So if I was to grab the first one, which is the one impacting the skin mesh directly, and I was to play around with its maximum distance, if I was to set it to 0, you can see what kind of an impact this whole thing is having as a whole. And I'm making sure that it's only impacting one side of the mesh. So what I'm going to showcase is what happens to these 2 deformation methods as the character is put in more and more extreme poses. With this initial triggering, I'm going to have you take a look from the front view what we have. We should really have about the same type of deformation, but there is a little bit of an edge that the directly applied Sculpt deformer has. You see, it's doing just a little bit more swelling, even though both spheres are moved to the same location on both sides. It just so happens that even with an initial application, the directly applied one is just slightly more impactful than the one that's coming through an intermediary blend shape. Now, at this part of the video, I should mention where this edge that the directly applied one has is coming from. It's primarily because of the input orders that these deformers are stacked in. So if I open my deformation input stack, you will see how things are arranged. Now, generally, when you are applying deformers to your skin mesh, you always want your blend shapes to evaluate here before the skin cluster. That is what is causing this, because the blend shape evaluates and then the skinning takes precedence over it. So it will abate some of the effect of the blend shape. That is not the case for the Sculpt deformer. We can leave it right where it's at. And that is what is giving it this edge of persistence over the blend shape. So keep that in mind as we scrub through and analyze this persistence that I'm talking about. And for one of them, I will move the Sculpt deformer lower in the stack underneath the skin cluster so you can see how it's primarily responsible for what's happening.